Welcome back to learning to program using the Godot game programming engine. Alright, in this video, a fella on YouTube asked if we could extend the race car game and add an AI opponent. So we're going to take a look at how to do that. Now, this is not going to be a super in-depth, intelligent AI. We're just going to do a real basic opponent so that you can play single player and see kind of how that would work. Alright, so first off, we're going to go here, and thankfully we'd already set this up with two separate scripts for player 1 and player 2. That's going to help out a lot because we're going to just totally delete all this for player 2. I apologize, I'm recovering from a cold, and so I'm a little congested still. So the basic idea of what we want to do is we want this car, we're going to make it player 2 here, we want him to travel around the track. So first what we're going to do is we need to figure out a way to make him aim at a location. So let's go ahead and do that. So I'm going to make him jump at the mouse, and I already found this guy right here in the documentation. Get viewport, get mouse position. That'll give me the position of wherever my mouse is located. One other thing I need to do is, I believe I'd set this project to full screen. Let's turn that off so that we can see it, see our debugger while we're going. So what I can do here is I can say var target equals get position. Alright, and then let's make our car point at that target. So to do that, all we need to do is say, if we look at our documentation at the node 2D, there's this function called LookAt. Now, if we wanted to make it turn slowly like the player does, we would need to look into some math. And here's an article I found on the math that we would need to do that. And so what this does is it basically returns the angle of the difference between 2 points. So we're going to do this, but Godot has helper functions, and that's this LookAt function built in to help us with this. But this is what you would need in order to do it slowly, so that the car doesn't just snap to the target location, it instead kind of rotates slowly. But that's kind of a more complicated topic and a little bit out of the scope of what we have time for here. So we're going to copy this, LookAt, and we're going to jump back to our car2, and we're going to say self.lookAt target. Alright, so let's play this and see what happens. So now you notice my car, my second car, is looking at wherever the mouse position is. So, excuse me. So we're going to simulate, we're going to use this to simulate the car driving around the position. So next thing we need to do is make the car move to that position. So let's do this. Let's say speed, which if we look back at player 1, you can see here when we accelerate using the forward button, we're setting speed to anything less than max speed. And max speed is defined up here in our car script, is set for 200. So what we're going to do for this one is we're just going to set the speed to, let's say, 120. And you can adjust this to be how fast you want your AI car to go, which would help adjust your difficulty. So let's do that. So here now my car is driving to it. Now it gets wonky when it gets at the position, but thankfully in our situation we don't need to worry about that. Excuse me. We don't need to worry about that because we're going to jump to the next position, so it'll work something like this. So as soon as it gets there, we'll snap to the next position. So let's go ahead and do that. So what we need is a set of positions on here to guide our car. Now this is called a NavMesh, or a nav tree maybe. It's been a while since I've looked at these, but basically it's a set of positions that are going to guide our car around. So we can do that with Godot just by using nodes. So I'm going to go ahead and lock this one so that I don't move it on accident. And I'm going to call this like my AI nav nodes. It doesn't really matter what the name is here, but we'll reference it here in a second. And then I'm going to make subnodes under here, and I'm going to use positions because they give me a little graphical representation of where I'm at. And so I'm going to set it right here, kind of in the center-ish, and I'm going to call it 1. And these don't matter so much what they're called, but I noticed in Godot, if you duplicate a node that's called a number, it just gives you the next number, which is pretty helpful for this. And the reason I'm doing 2 nodes here, and you'll see it in a second, is it helps the car look a little bit smoother and more natural as it goes around the corners. And you can add more nodes to add more smoothing if you wanted to. So we've got all our nodes set up, and they should go 1, 2, 3, 4, 5, and I can read the number there a little bit above and to the right of the node as I hover over it. And you can see they're here in order. Now it is important that they're in order in here because we're going to use this property of the children of this node in order to find which node to go to next. So let's save this and go into our script. So I need a couple variables up here. I need a onReady var nav, let's call it AI nav nodes. Alright, and then that's going to be, let's do nav nodes equals, and then get node, and then we can just drag this in like that, save us some typing. And then I need another one for var AI current nav index. Alright, and then we're going to set that to 0. And that will represent the first node right here at the number 1. And this is a 0, or what we're going to be looking at is, if you look on, oops, I meant to look on a node. If you look at a node, there's these get child and get child count. We're going to use these 2 functions in order to get these children and then know when we've reached the last one. And they're 0 based, so what that means is this is 0 and this is 7, and then it'll loop back and we want 0 again. Alright, so let's jump into my code again. Alright, so I've got the index and I've got my reference to this node. So we want to change this target based on that. So I'm going to comment this out, and instead I'm going to use var target equals AI nav nodes dot get child, and then I want to get the child at this index, but I don't need the child itself, I need the position that it's at, because before I was getting that mouse position, now I want to get the position of that node. Alright, so that should change my target. So if I play this, what should happen is I should just drive up to that first node right there. Perfect. Now I need to know, when I get to that node, I want to go to the next one. So what I can do is, let's just combine those 2, and then, so I need to know when I'm close to that other node. So what I can do is use the distance property. So if I look again at the documentation and I look at a node 2D, there is a helper function, not here, it's on a vector 2, which my position is a vector 2. Let me go back to that so that you can see that. So my position right here is a vector 2. So I'm going to click on that vector 2 and this will give me the stuff here. So here I have distance 2. And we're going to copy that. And then I'm going to jump back here. So what I want to do is say if self.position dot distance to, alright, so that's saying the distance from myself to some other location, and the other location I want is target. So the distance to target is less than, and then some value, and I'm just going to make up a number here. It's not super important, but this will be the distance this car has to be to this before it switches to the next node. So if it's too big, he'll turn too early, it'll switch too early. And if it's too small, it'll feel a little bit, well, you may actually run into problems. If it's too small, it'll just sit here and it won't be able to detect that it's actually got there. So anyways, you might have to fiddle with this number, but we'll just start there. Because what may happen is the car's velocity may move it past that amount, and then it'll turn around and come back, and it'll just sit there and wobble on it instead of moving on. Alright, so if that position, then I want to say pick next navigation node. Now this function doesn't exist yet, so let's go make it. And we could just code it right there in place, but I think this will be a good place for us to do this and help keep our code nice and clean. So let's see. What we need to do is take this index equals this index plus 1. Alright, so that'll bump this will go from 1 to 2, and then 2 to 3, all the way up to 8. Now here, I want to say if if this is greater than or equal to AI nav nodes dot get child count. Remember I told you we were going to use that other function there called get child count. This returns this number right here, which in this case will be 7 because it starts with 0. Right, so I'm using the greater than or equal to, so that actually it may return 8. Let's print it and we'll find out. So this I want to print. So we'll just print it right here and we'll see. But I do have to finish this line. So if it's equal to that, then we want to set it back to 0. So what we'll do is set this AI current index back to 0. Alright, so that'll restart my loop. So here we go, and so it's 8. So it's actually returning 8. So what's happening is I'm counting up 0, 1, 2, 3, 4, 5, 6, 7, and then I'm going to 8, and then this code triggers that says if it's 8, then set it back to 0. So that's what I want, and this is a little bit confusing. I could number these 0, 1, 2, 3, 4, but I'd have to go through each one of them and do that. Maybe if you were doing it and you wanted to, you could. Just be aware that it uses 0 indexing. And that's pretty common in programming. So yeah, so let's go ahead and try this. Give it a shot, see if I can beat this guy. Now he doesn't accelerate. That's one of the it's hard to drive and talk at the same time. That's one of the concedences we made, is we just instantly accelerate him up to full speed. We could maybe try and do that. So I think I could beat him if I could drive very well, because I'm able to go up to the max speed of 200, whereas he's stuck at his 120. The trick is to turn early, get your turn started. Oh, there we go, there we go. And so the nice thing is I'm still able to bump into him, and you can actually block him, but he will what I probably should do is make him slow down as well if you bumped him. So we could do that, but I'll leave that up to you. One thing we could try is we could try the acceleration, to add in the acceleration. So instead of just jumping him straight to 120, is we can instead move his acceleration up. So the way this worked before is we said we'll just take this whole thing right here. We'll we'll just assume his pedal is to the metal. So we'll say if speed is less than max speed, then acceleration times delta. So this will just cause me to accelerate. Now instead of max speed of 200, let's set him to 120. This is how you would adjust the difficulty of the AI. So now you see he takes off 2, which gives me a little bit more of a fair start. And if I block him, he's got to start back up too. So he doesn't just immediately take off. He's got to speed up a little bit as well. So I think this is a pretty decent little simulated AI for racing. Now there's lots of things you could do. You could add more nodes to give it a little bit smoother turn. You could also add variance to these nodes, and you could also, if you wanted to, instead of driving directly at the target, you could add a little randomization. So let's try that, maybe. So the problem here is I'm getting this every frame. I'm getting this new position. So what I would probably want to do is, let's see. Yeah, you would probably need to store the target until it reached the next position. And then what you could do is add a little bit of variance to it. So the way you do that is you'd have a var current AI current target equals null, and then you could say here target position, and then if AI current target position equals null, then let's get the next position. Oops. So that's my target, and I want the next one, or so I want to randomize this a little bit. So if I look at my if I look in my code, or my help here, I have randomize, and then let's see. Rand range from and to. Okay, so what I want to do is I need this randomize up here in the top. Alright, and then here I want to say target.x. Let's look at our position. Vector 3, nope, I want a vector 2 position. Yeah, so it has an x and y, so I should be able to just access those directly. So if I say target x equals target x plus rand range, and here I'm just going to add a little variance of let's see, let's add a variance of 10, negative 10 to positive 10. That's actually a pretty big variance. It's a variance of 20 units. Maybe too much, but we'll see. You can kind of get an idea of that by clicking on this, and does it display the position anywhere? It does not, unless we look at the transform over here. So the transform over here, right, so right there it's at 155. So way over here at 145 is how much it can move. So it's kind of like that kind of variance right there. That's a real rough approximation, but let's go for it. And then same here, target y equals target.y plus rand range negative -10 to +10. So let's see how this works. I do need to finish this. So this gives me my target position. Right, but I'm using target everywhere else after this. Oops. I did not want to do that. I wanted to do this. But this would be null, so what I need to do is make this, let's see, right, equals vector 2, 0, comma, 0. So this will just override it'll create a new one that's at 0, 0, and then override them with these values. It'd probably be easier to paste this stuff in here, but I've already got this written. So let's see. Excuse me. And then don't need this anymore. And we're jumping out. Let's see. Why is this red? Target. Ah, okay. So it doesn't like target. So what we need to do is instead use this. And that for that. Okay, so the only other thing we need to do is when we pick a new navigation node, we need to do this again. And the easiest way to do that would be to set this to null, but what will happen is if I picked it and then I did this LookAt, it would blow up. So need to move that above that, and then we're going to say, oops, did not mean to do that. We're going to say current target position equals null. So that'll reset that and force it to rerun this code and repick the next node. Alright, so let's try it. So there he goes. And yeah, I'm not sure that was worth the effort, to be honest, but it did add some variance, because you notice he's not driving exactly the same way and hitting those nodes precisely where in the center like he was before. So it gives it a little bit of more challenge. Now if your numbers were too big, he'd probably go off and hit the walls. So let's actually try that. Let's do a var AI rand offset, rand max equals, and instead of 10, let's go with like 30. Alright, and then we're just going to replace that here, 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 and here. That way I can just change that one number and it'll affect it everywhere. So there you saw he took a real tight corner right there. And there he's drifting out pretty far. Yeah, he's driving pretty wild now. I'm driving worse, but yeah. Alright, so yeah, I'm not sure that was, and there he crashed into the wall. So the number was too big and he got stuck, and that was not good. Now if you made this too tight, you know, like 2, you're not even going to see it, and we basically just wasted our effort doing all that code, because he's going to drive just like he would have before without those values. So anyways, alright, I hope you enjoyed and I hope this helps. If you wanted to make multiple AIs, all you'd have to do is duplicate your player 2, and the big problem would be is if they were all on the same nav path, they would all try and crash into this point right here before they change to this point. So that would be a problem. This variance code would probably help quite a bit with that. You could set this variance up to be, you know, kind of large, but not so large that they were hitting the walls. And that would help them not all have to go to this point. You know, one may go over here, another one may go over here. That would help a lot. Let's see. You could also maybe figure out an offset off from here based on their location, you know? So like if there's a car over here on the left and he's already on the left, maybe he tries to stay on the left. But, you know, that may not be optimal, right? Like the optimal driving path would be to keep the corners nice and tight. So I don't know. You know, there's lots of options here. Of course, there's no intelligence behind these. They're just driving from one point to the next. Intelligence might be, you know, trying to block the player or optimizing the way they turn. That would be more like a neural net kind of thing, and you'd have to run lots and lots of runs, and it would try, you know, different turns and see which one was most optimal. That would be very intensive and would take a lot of time. There's videos out on YouTube on how that's done. You might want to check those out if you're interested in that. But I think this is probably, you know, a pretty good scope of difficulty to effective AI for doing a little opponent here. Alright, hope you enjoyed, and I'll talk to you next time.